Hello friends, I'm Mohnish and I'm back with a new video. So today we are going to discuss a very simple topic which is doing some things in our Carla simulator and we'll be knowing what the things are. So to be brief, we are going to get the data of all the objects nearby the car using the LiDAR sensors. And so let's get started with the code. So here we imported things, we called a Carla, we imported Carla, actor list, and we'll talk about this function later. This is object IDs, so we'll talk about this later and this function also later. And this we are going to talk about it now. So this is applying control with throttle 0.51. Throttle is the velocity. It's okay. So let's get from here. So we are connecting to our Kala world. We are getting the map. We are getting the blueprint library. We are make spawning the car. Then car model spawn point, walker's blueprint. We are, like this is how you spawn a walker, and you give it a direction. So this is a code for some other day, like not important for today. And this is simulated camera rotation, location, and all that. So this is our part of interest. So let's discuss this part in detail. So we are trying to generate a LiDAR sensor using the generate LiDAR blueprint. And we are giving the blueprint library like so this is the blueprint library which has all the data of the world, and we are going to jump to this function control F and find all. Oh no, not this one. Control F. Okay, so here we are. So now this generate LiDAR blueprint has a parameter blueprint library which is given as the blueprint of the world. So from that we are finding the semantic LiDAR sensor. There's a difference between LiDAR and semantic LiDAR. So we have Google for this. Like Google can say the difference better than me. Difference between LiDAR and semantic LiDAR. Semantic LiDAR. You can see images. So you see to uh I think okay, so they are talking about segmentation. So I think we don't have anything much in the this versus this. So I'll just say it in brief. So LiDAR sensor will give you like very less returns. Like it will give you distance, like not distance. So you have to calculate it using the 3D vectors, like using the square root function, and we have to square the XYZ vector, and we have to root it. So distance is not given. Then we get few parameters, which will be seeing in the function here. But here in semantic ladder sensor, we also get more parameters like object tag, which object, the ID of the object. You get a lot of stuff. So that's why semantic ladder later is used, and LiDAR does not have any color code like encoding before. Like objects near you, green, red color, far, green color, medium, yellow color. So, but that is not shown for LiDAR. It's only shown for semantic LiDAR. And semantic LiDAR is way better, like in somewhat, like it's somewhat way better. Like it has a better view in the Z axis, like Z, X, and Y axis than the LiDAR. So, like normal LiDAR. LiDAR has a good view in the X axis, but in the Z axis, it does not perform well. So, that's why we use semantic LiDAR. Then channel 64, like these are the processing units, points per second, like how many laser beams or light rays will it send in a second. So 56,000 rotation. So LiDAR rotates about the axis which is placed above the car. So I can show it using image. LiDAR on car image. So you see, this is how a LiDAR is kept on a car. So you see that thing keeps on rotating and collect the data. And that's very fascinating. Like it will rotate 80 times in a second. So very fast. Yes. And we are setting the range like distance of 100 meters. So what is this object ID and things? So uh in Carla, you have few objects, not objects, a class of objects. Like buildings is a class in which you can have Burj Khalifa or the Imperial State, Statue of Liberty, even the Sarat City Mall. You can have anything. Fences can be wooden, oak wood, dark oak wood, then acacia wood, and all that. And pedestrians can be girl, boy, old, and all that. Poles, road lines, solid, and all that. Roads, sidewalks, vegetation, vehicles. Vehicles you have seen. Vehicles dot you see here. We are using the vehicles dot. Okay, so we are just filtering the model 3. So we can also give this model 3 like this: vehicle dot model 3, like that. So we can give it like this also. Uh, so vehicle is a class which has another class of vehicles, like a smaller class, which has the actual vehicles. So you can see it like this, like a folder structure. I'll just control N. So I'll just give you my quick view. So you can see that vehicle is a class. Okay, so I'll just try to make it a. So in the vehicle class, you have something called Maruti, for example, a company. So that is making Desire, Ciaz, Vitara, and then you have another class which is, for example, I don't get any company. Okay, Honda. So it has a car named Honda City. I'll just write City. Then you have a company, more companies like that. So this is how a thing is called. Okay, so now I'll just name it Carla is the main route, and then I'll just tab all of this, and then you can have things like here sensors. So you have a folder which is, let's see, like what was the Carla. So this is Lidar. So in Lidar you have two, which is Raycast, the normal one, and then second one is Raycast Semantic, and then you have the normal other, then you have radars, then you have camera, you have RGB. So like this, the things are stored like class to class. So you understand how it's stored. So this is a simple thing. So for the main class here, not for color, these classes. So if it is vehicle, the object ID which is given to it is 10. Like that's how the color documentation says this. We copy it. That's it. So ground is regarded as 14, water as 22. So you understand what are these indexes. So I just try to show you in the like JSON format, like how would it be in JSON format, but it could you like this is what it looks like, not like that. So okay, so then we are making a list of the key list, like key values. It's a dictionary and list of the IDs. Okay, so that's very simple. Like if you have got confused, rewind the video, watch it again. There is no harm in that. So we generated the LiDAR sensor. Yes, we just generated it. We did not know much. Then just setting the spawn point, not of much importance. You know it. Like I know, you know it because I taught you many times. Yeah. So sensor is equal to world spawn actor. We are spawning actor. The what is the sensor? LiDAR sensor, which is this one, and we are setting the spawn point to this, and we are attaching it to the drop vehicle. Very simple. And then we are calling a lambda function like sensor.listen lambda point cloud data. So point cloud data is the, you can say, argument like which you have to give. It's a positional argument, and we are calling like what we have to do. We have to call this function with this thing, like with this parameter like argument. So let's get through this function. Okay, control AV. Yes, so we got this. So we are making a dictionary distance name data, which can of course be omitted. You can make lists of them, like, but dictionaries is better, like in some ways. Like I feel it's better to use. And then we are getting the position. So I'll just print the detection for you, like for now. like print detection, and I'll just comment out this code for some reason, like, and we'll goes to cmd, okay, help.cmd control. Okay, so here control T doesn't work, so I need to click help.cmd, and here one more, which will be cd slash cd windows no editor. Okay, windows no editor, Carla, quality level low, and then we are going to cd examples. Okay, cd examples, python spawn npc n equals to 100. So we spawn 100 vehicles or actors, and then we are going to go through cd project code, then python project, what is this, 219? Yeah, okay, 219.py. Okay, let me set these things. Yeah, so I really don't know where this thing is going to spawn. Like I just gave a random spawn point. Okay, let me stop. Use, okay, okay, control C. Okay, okay, wait. Okay, so now you see, we have the semantic lidar data as x, y, z values. We are getting the cos incident angle of the light ray, and we're getting object ID x and object tag. So what we are going to deal with here is object tag. So object IDX, like you can think of this, like, so this is the object tag, vehicle is given 10. So in that we are having the 0, like that, you can think like that. And then object tag. So we are going to deal with the object tag here, nothing else. So take your seat belts, and we are going to have a harsh journey, like, so we'll just comment this, like, why do we need this now? So we're getting the value index, and we are trying to index, like index is a function, and detection with object tag. So what is this? So we have a list of the values. So from that we are sending a value, like for example it's 10, it's a vehicle. So dot index will give us the index of that element in that list, if you understand what I'm saying. So it will simply return us 10, because 10 is the index. So we're using this to get the name, key list, position. Position is the, like, index, like we are, it's written going to return an index, so we are using the same index to get the keys. So as it is a ordered list, like dictionaries are ordered unlike sets, so the list will also be ordered. So there's no need to fear that it might mess up. So I said you the distance is calculated using the detection dot point dot x. uh asterisk asterisk means to the power of 2. We are adding this to the y power 2, z power 2, and we are square rooting. It will give us a estimation, approximation, not the actual value, to mind you. And then we are setting the distance, like to distance, which we set here, and the name to key list dot position. And we are printing the objects near it. Very simple, right? No. Until we run it, it's not simple. So let's run it. So I'll just clear this junk, and we'll just call a code. Okay, what I'll do, I'll just spawn the vehicles once again, and I'll just change the spawn location, like, to somewhere around 0. Like I don't like 20. Like it's spawning me in some other place. Like I don't like that place. Like I don't see my car directly. That's a problem. Like it's just in a footpath, in the middle of the footpath here. So okay, I think I lost the track of my car again. I just jumped away somewhere. You see, but we are getting the data, like what's near a thing. So LiDAR is capable of detecting, like it can detect what thing is near you. Like if it's a vehicle, you're going to stop. Pedestrian, you're going to stop. In fact, if there is anything in front of it, we are going to stop. So we are going to use this data in the coming videos, and we are going to create a smart car system, like which will not crash into anything. Of course, we are going to come with traffic lights and all that. So I don't know, for some reason there's a lag. So you see this Tesla Cybertruck? Yeah, it's my favorite car. Like it's a big car. So that's it for the video, friends. I think it's going long, but thank you for watching the video. And if you like this video, subscribe to this channel, share this information with everyone you know. Everyone should know about Carla, and Carla is for everyone. With that said, thank you, friends. Take care. Bye bye.